Somewhere in the world right now, someone is eating something that is, by every biological definition, attacking them. Their mouth is on fire. Their eyes are watering. Their nose is running. Every signal their body can send is screaming the same word: stop. And they keep eating. They go back for another bite. They order it again next week. Some of them chase down peppers so intense they've been known to send people to the emergency room. And they do it for fun. No other species on the planet does this. Not one. Every other animal on Earth treats capsaicin, the compound that makes chili peppers hot, exactly the way it's meant to be treated. As a warning, as a reason to walk away. Researchers have tested this over and over. Give a rat food laced with capsaicin, and it eats it once, then avoids the stuff entirely, sometimes for the rest of its life. Dogs sniff a chili, recoil, and won't go near it again. Every mammal studied responds to that first exposure the same way. Learn the lesson, walk away, never look back. Humans are the one species that heard the warning and decided to lean in. So what's actually happening in your mouth when you bite into a chili? Here's the strange part. Nothing is burning. There's no heat, no fire, no tissue damage at all. Capsaicin binds to a receptor on your nerve endings called TRPV1, and that receptor's entire job is to detect real, physical, dangerous heat. Like touching a hot stove. Capsaicin hijacks it. It tricks the receptor into firing exactly as if your tongue were being scorched, and your brain gets a 5-alarm fire signal from a mouthful of vegetable matter. The scientist who mapped this out, David Julius, spent years working out precisely how that receptor functions, and in 2021, he won the Nobel Prize in Physiology or medicine for it. What he found was that pain and heat run through the same wiring in your nervous system. Capsaicin doesn't create a new sensation. It breaks into a system built for something else and pulls the alarm. Which raises an obvious question. Why would a plant build a molecule whose only purpose is to set off a false fire alarm in whatever eats it? Because the chili isn't trying to stop everything from eating it. It's trying to stop one specific group. Peppers need their seeds spread, and they need those seeds to survive the trip. Mammals are a problem for that. Mammal teeth are built for grinding. Flat molars designed to crush food into paste, and pepper seeds get pulverized along with everything else, destroyed before they can ever grow. Birds are a different story. Birds swallow seeds whole and pass them out intact, sometimes miles from the parent plant. So the pepper needed a way to repel one group while staying invisible to the other. Capsaicin does exactly that. Birds have almost no TRPV1 sensitivity to it. A bird can eat the hottest pepper on the planet and register basically nothing. Mammals get the full alarm every time. Researchers studying wild pepper populations, including work led by biologist Joshua Tewksbury, found this pattern holding up again and again in the field. Birds feasting on the same peppers that squirrels and other mammals wouldn't touch twice. The plant built a lock, and only one kind of animal happens to hold the key. Which means every time you eat a chili, you are voluntarily disabling a defense system that took millions of years to evolve, one specifically engineered to stop mammals exactly like you. That's the image worth sitting with. Somewhere in a forest, a bird lands on a pepper plant, eats without a second thought, and flies off. A squirrel takes one bite, recoils, and never comes back. And a human walks up, watches the whole standoff play out, and thinks, I'll have that. So why do we do it? Why is our species the glitch in the system? First, worth knowing, nobody is born loving spicy food. Babies who taste capsaicin for the first time react exactly like every other mammal. They cry, they refuse it, they push it away. If liking chili were written into human biology from birth, every culture on the planet would have discovered it independently and at the same rate. They didn't. Entire regions barely touch spice, while others build every meal around it. Paul Rozin spent years studying this gap firsthand, watching children grow up in villages across central Mexico, where chili appears at nearly every meal. Even there, liking it wasn't automatic. Small children rejected it just like children anywhere else. It took years of small repeated exposures, usually mixed into food by parents in tiny amounts, gradually increasing, before a child's reaction shifted from rejection to actual enjoyment. Nobody is handed a taste for chili. It gets built one exposure at a time. The same way a person slowly works up a taste for coffee or beer, both of which most people also hate the first time. Part of what makes that possible is a trick your body plays on itself. When it registers what it thinks is real damage, it responds the way it would to any injury. Releasing endorphins to dull the pain, alongside dopamine from your brain's reward circuitry. Normally that combination exists to help you survive something genuinely painful. But because you know on some level that a chili isn't actually going to hurt you, your brain gets the rush without any of the real consequences. Rozin gave this a name: benign masochism. It's the same reason people ride roller coasters, watch horror films, or jump out of planes with a parachute strapped on. Your body reacts as if you're in danger. Your mind knows you're not. And somewhere in the gap between the two, a lot of people find something that feels a great deal like pleasure. But that still doesn't explain why entire regions built their cuisines around it, while others barely touch it. In 1998, researchers Jennifer Billing and Paul Sherman went looking for a pattern and found one hiding in plain sight. They compared traditional recipes worldwide against climate, and the correlation was almost too clean. Hot countries use dramatically more spice than cold ones, sometimes many times more. And the reason has nothing to do with flavor. It's bacteria. Meat spoils faster in heat, and historically, before refrigeration, that spoilage could kill you. Many compounds in spices, capsaicin included, are genuinely antimicrobial. They slow the growth of the exact bacteria responsible for food poisoning. Cultures in hot climates that leaned into heavy spicing weren't only chasing flavor, they were protecting themselves. Over generations, the habit became tradition, the tradition became identity, and eventually spice stopped being a survival tool and simply became something people loved. And once that habit took hold, it didn't stay in one place. Chili peppers evolved entirely in the Americas, nowhere else on Earth. Cultivated by indigenous peoples in Mexico and Central America for thousands of years before anyone outside the continent had tasted one. That changed almost overnight. When Christopher Columbus landed in the Caribbean in 1492, he was actually searching for black pepper. He never found it. What he found instead was chili, and he carried it back to Europe believing he'd discovered a new kind of pepper. From there, it spread at a pace that startled even the historians who study it. Portuguese traders carried chili seeds to Africa and India within decades. By the 1500s, dishes across parts of India and Southeast Asia were already built around a plant that a century earlier had never existed outside the Americas. Today, it's almost impossible to imagine Indian, Thai, or Sichuan cooking without it. All of it tracing back to a single plant family native to one continent. So the same molecule a plant built to repel you became a source of comfort, tradition, and even joy. Then rode that transformation across the entire planet in a few hundred years. Every other mammal still obeys the warning exactly as designed. We're the only ones who turned that warning into a craving, then built entire cultures, cuisines, and identities around chasing it. Somewhere along the way, we didn't just override a defense mechanism millions of years in the making. We fell in love with it, taught our children to fall in love with it too, and carried it to every corner of the world we ever reached.